So last time we wrote our first smart contract in Solidity. We also wrote our first function, which is this create NFT function, and now it's time to actually test these things. So let's go to the test folder. So the test folder is where all of our test files should be. Let's open the index.ts file, and as you can see, we have some uh, sample code here generated by Hardhat. So this was originally testing the greeter.sol smart contract. It was in the contracts folder, but we deleted it, if you remember. So yeah, it makes sense that this test won't pass anymore. It will fail. So let's go ahead and try to run it. To do that, let's run npx hardhat test. So as you see, it compiled our smart contracts and then the test failed. Um, the error is artifact for contract greeter not found. So basically, uh, all the contracts under the contracts folder were compiled and artifacts were generated. So if you go to artifacts/contracts, we can see that we only have one folder here, the NFT Market.sol. We don't have any artifacts for greeter.sol, and hence this error. Now we don't I don't need this code, but I'm gonna keep it. I'm just gonna comment it here so I can get inspired from it. Now we're ready to start writing tests for our contract. To write tests, we always use the describe function from Mocha or Mocha. I still don't know how that's pronounced, sorry. And the describe function takes a description. So I don't know, let's call it NFT market, right? And then a function. And inside this function, we can actually write our tests. So to write a test, we either use it, just like what they did here in the sample code, or we can use tests. Both work the same way. Um, so I'm just gonna use test because it's more readable. You can say it, and then it should do something like this. It should do something, right? And then it also takes a function where the uh, code for our tests will be. So in order to test our contract, we first need to deploy it. And to deploy a contract, we use these three lines. I can basically just copy past this, change it to NFT market, and it will work. But let's not do that. Let's actually write it from scratch. So const NFT market equals await ethers dot get contract factory and pass in the contract name, which is NFT market. So NFT market, and it complains because this function should be marked as async. The next step is to call await NFT market dot deploy. So this will actually deploy the contract, and it returns an object that we can store in a variable here, NFT market. So as you can see, this is capitalized. This is not. You can think of this as a class, and this the instantiation of that class. So object-oriented stuff. And then we should actually await for the contract to be deployed by doing await NFT market dot deployed. So these lines deploy the NFT market contract. After this, we should be able to call functions from this contract and do all sorts of things. So uh, the function we are interested in is the create NFT function. So let's go ahead and start testing it. This create NFT function takes a token URI, which is a string. So the first thing is we need to get or set a token URI here. So let's do https // some token.uri. I don't know, just make it look like an actual URI. It doesn't matter what the value of this is, but you will see what I'm gonna use it for. Now let's go ahead and call the create NFT function, and to do that we just do NFT market dot um create, what's it called? Create NFT, passing in the token URI. And as you can see, this function has any type. So like all of the functions that you write here will have the any type, and also the return value is going to be of type any. So just keep that in mind. So this actually is an async function or operation, so we should await it, and it returns a transaction object. So we can store that in a transaction variable transaction like this. Mhm. So this transaction has a wait function that we can await for. So awaiting that function makes sure that the transaction was mined, and it actually returns a receipt object. So let's go ahead and do receipt equals wait transaction dot wait. So let's explain what these variables mean. In a front end, so in a browser, when you call NFT market.create NFT like this will trigger a transaction, and your wallet, either MetaMask or any other crypto wallet, will pop up and it will ask you to confirm this transaction. And while the pop-up is open, we will still be awaiting this operation to like resolve, right? So once you confirm the transaction, the await will resolve, and then we will go to the next line. And if you like decline or close the pop-up, I guess it will throw an error. So yeah, it will trigger a transaction, wait for it to be confirmed by the user, and then it will return a transaction object, and that's what we store here. We can go ahead and console log it to see how the transaction looks like. So let's go and run npx hardhat test. So this is the transaction object. It has a bunch of information here, and it has the wait function that we used here. Awaiting this function actually waits for the transaction to be mined. So when you confirm a transaction, it will be sent to the Ethereum virtual machine, and it will take some time to be confirmed and to be mined. So awaiting, the wait function actually waits for all of that to happen, and it returns a receipt object. We can also console log it to see how it looks like. So as you can see, it has a bunch of information here. It has an events array that we are going to use later, just now actually. So I hope these three lines all make sense to you, and like we can comment this as call the create NFT function. Yeah, I think that's good. So now we are ready to assert stuff, right? The first thing we need to assert is that an NFT was created, and that NFT has this token URI, right? So let's go ahead and do that. So let's go and Google ERC721, open Zeppelin, and I don't know why it always takes us to the 2.x version. It should take us to the latest version. So go to ERC721, and I guess there's an ERC721 URL storage link here. So one of the functions of ERC721 URI storage is the token URI, right? And token URI returns the uniform resource identifier um, for the token ID. So you can call token URI, pass in the token ID, and we will get that token URI string basically. So first, we need to get the ID of the newly minted token. Now, we already know it's going to be 1, right? So it starts at 0, it increments, and the first token will have the ID of 1. We can do that, but a better way is to actually grab the token ID from the receipt object. So the way we can do that is by using events. If we go to ERC721 here and search for events, we can see that there's a transfer event here. So it is emitted when token ID token is transferred from to 2. So I already know that this event is emitted when we call the SafeMint function. So let's just go and check it out. So ERC721, um, GitHub. It's so nice that we can see the actual code. Let's search for SafeMint, and this is the function that we call from here. SafeMint passing the 2 and the ID. So this is the one. It also calls SafeMint with 2 token ID and an empty string, which is this one. It has 3 parameters, and this function, it also calls the mint function. So if we search for mint, this is the main function. So you can see it does a bunch of stuff, and at the end it emits a transfer event, passing in the address, the 2 address 0 I mean, and 2 and token ID. So the way that events work is you can actually, like, let's do a test event here. So to declare an event, we use the keyword event followed by the event name. Let's do a test event, and in the arguments, we just pass in whatever arguments we should pass to the event. So test ID, for example. And in our code, we can use the emit keyword to emit an event followed by the actual event, and we should pass a parameter here. Let's do 1, 2, 3, for example. So this is the same thing that's happening here, right? And let's just delete this. The event that's been emitted has 3 arguments: the address 0, the 2, and the token ID. We are interested in the token ID. That's the thing we want to grab from the receipt. So let's look at our receipt event again, receipt object, I mean. So we are interested in this events key, which is an array. So the first object of that array is the actual transfer event. As you can see, event is transfer, and it has an args key. That args is an array that actually holds these parameters, right? So we are interested in this args value. So the way we can grab that is we can do const args equals receipt dot events at index 0 dot args. So let's console.log args and see how they look like. So the args object has all the parameters that we saw here. It has the from, the to, and the token ID. We are interested in the token ID. As you can see, it's a big number. It doesn't really matter. So we can do token ID equals receipt.events.args dot token ID. Now it's time to call the token URI. Um, this function that we just talked about. Um, so let's do const token, or let's do minted token URI equals NFT market dot token URI, passing in the token ID. And as you can see, the token URI function takes a token ID, which is unsigned int 256, but here we send a big number object, right? This is not a number. It doesn't really matter. As I said, you can send a big number, you can send an int, you can send a string here as a parameter. As long as it represents a number, you're good. So let's pass in the token ID, and it's time to finally assert something. To do that, we use the keyword expect, and we expect the minted token URI to equal the token URI that we sent to the function, this one. So to equal token URI. Let's run our tests. So it says, oh, oops, I forgot to await this. My bad. Mm, invalid. Oh, I guess this is token IG here, right? It sucks not having TypeScript. Yep. So what we just did is we grabbed the token ID of the newly created NFT, called the token URI function, passing in that token ID. We got the token URI, and we tested that the newly created NFT's token URI is actually the same token URI we sent to that function. So that's the first test. Let's comment this as assert that the newly created NFT's token URI is the same one um, sent to the create NFT function. So that's one test we can run. Another test is to assert that the owner of the newly created NFT is the actual user who initiated the transaction. So um, to do that, I believe there's a function um, owner of. Yeah, there's an owner of function. It takes again an ID and it returns the owner of the token ID token. So we can do const owner equals await create or NFT market dot owner of token ID, right? And we should assert that this owner, this is an address, that this address is the same as the current user address. So to get the current user address, we can do const signers equals await ethers dot get signers. This will give us an array of signers. And if we don't specify what signer should use the contract here in the code, it's always the first signer, right? So all of these transactions were made by the first signer. So we can grab that address of the signer. So address equals signers at index 0. So the first signer dot get address. And this is promise, so we should await it. And finally, we can expect that the owner, we should call this owner address, and this current address. We should expect that the owner address uh, to equal the current address. Let's test. Yep, it's still passing, so great. The newly created NFT is owned by the user who, or the address that initiated the transaction. So let's comment this. So yeah, this is how you test your smart contracts, and keep in mind that this code is the same code that you would write in a front-end project. The only difference is that you won't import ethers from Hardhat, you will import it from ethers. Otherwise, everything should work the same. Now, there's one more thing I want to talk about, and I feel that this needs to be clarified. If you have good attention to detail, you're gonna notice that we called two different functions from our NFT market contracts, but this function, the token URI function, returned the expected return value. So this returns the token URI and we got that token URI immediately and we used it here. So calling this returns the expected return value, whereas calling create NFT function return the transaction object. And if we go here, we can see that it returns an integer. We return the current ID, but we don't have that current ID. We actually got a transaction object. So why is that? To answer that question, we need to learn about view functions. So let's Google view functions Solidity. Because I've already Googled this, if we go here, so this is a nice explanation about view and pure functions. So I'm just gonna read this real quick. Getter functions can be declared view or pure. View function declares that no state will be changed. Pure function declares that no state variable will be changed or read. Uh, Before going any further, we need to know what state is. Basically, state is any variable that is declared outside of any function. So all the contract variables are state variables and they are persisted um, and basically they're stored in the blockchain. So as an example here, our NFT market contract has one state variable. This is the only variable that is declared outside of any function and it is stored in the blockchain. So, as you can see here, the add to x function has the view modifier, so it's a view function, and it promises to not modify the state, and it does not modify the state, it just reads it. So it reads x and it returns x plus y. Y is sent in the parameters. Now, the pure function adds to the view function another condition. It promises to not even read the state. So as you can see here, we're not reading any state. We don't use the x variable, so we don't read any state. We just return the sum of the parameters here. So this is the view and pure functions. Now that we got that out of the way, we can see that the create NFT function is not a view function because it does change the state. So when we do token IDs dot increment, we actually add one to the token ID, so that's one change. When we do safement, set token URI, all of these operations write to the state. So this is not a view function. Now, the token URI one is a view function. Let's go ahead and check that. RC721 GitHub. Um, let's search for token URI, and here it is. It is a view function, and as you can see, it doesn't change any state. It just reads it and returns a value. So that is the difference between the create NFT, which that is not a view function, and the token URI, which is a view function. When calling token URI, we immediately get the expected return value because it is a view function. When calling create NFT, we get a transaction object because this is not a view function. All the functions that alter the state trigger transactions. So as I said, if you call the create NFT function from the browser, your wallet will pop up and ask you to confirm. And once you confirm, a transaction will be sent and you'll have to wait for it to be mined and then you'll get a receipt object here. So non-view functions trigger transactions. That's why we get a transaction object as the return value. View functions do not change in state, so they're more like simple API calls. So we get the return value immediately. I hope that this all makes sense. So if you ever call a non-view function and you expect the return value to be the one returned from it, and it's not, this is why. So yeah, I guess this is the end of this video. See you guys in the next.